Alright guys, here we go. Try this one more time. Today we're going to talk about arithmetic sequences and series when we're going to add up part of our sequences. Okay, we've already talked about arithmetic sequences. Notice again, we talk about how each time we're going up by a common difference. Okay, so if you add or subtract a specific number every time, that's called the common difference. A is known as the first term, so to find the nth term, you can use this equation right here. A sub n equals A, which is your first term, plus n minus 1 times d. I use a little bit different one, but I'll show you how that rolls, so just get ready. Here we go. So, already talked about that. Let's go ahead and look at slide 7. So slide 7 here says, okay, find the common difference, the first 6 terms and the nth term and the 300th term. So if I look at this, my common difference between all of these, 13 to 7 is minusing 6. 7 to 1 is a minus 6. 1 to negative 5 is a minus 6. So I could write the nth term. So they already given me 1, 2, 3, 4. They already given me the first 4 terms. If I want the first 6 terms, I just have to go 2 more. So it would be negative 11. Subtract 6 more, and then negative 17. Subtract 6 more from that. We know that 13 is our first term, and our common difference is a negative 6. So we would get A sub n equals 13 times, I'm not sure why that did a triangle there. We get 13, which is our initial term, minus 6 is our common difference, times n minus 1. Okay, another way to think about this or look at it is this. This is how I kind of look at it, all right? So I look at it like this. I say to myself, all right, if I'm subtracting 6 every time, repetitive addition or subtraction in mathematics is multiplication. So that's really negative 6 times n. Now, this 13 is the first term. So if I plug a 1 in here, I get negative 6 times 1, but I don't want to get out negative 6. What I really want to get out is 13. How do I get from negative 6 to 13? Well, I add 19. So this would be a plus 19. I could check the second term out by plugging a 2 in. Negative 6 times 2 plus 19. Negative 6 times 2 is negative 12. Plus 19 would be 7. That second term should be a 7. There it is. You could check out the third term if you wanted. Negative 6 times 3 is negative 18. Plus 19 is 1. You should get out a 1. If you look and distribute in the negative 6 here, you get negative 6n minus 6, and then you get 13 here. Combining like terms, this would be plus 6. Combining like terms, I get negative 6n plus 19, which is exactly what I got up here for my A sub n equation. Okay? So, let's go ahead now look at our next page. What do we want to look at? Oh, they did want us to find the 300th term. So, if you just take 300 and you plug it in, you would get 300 minus 1, which is 299 times 6, and then 13 minus that. Well, 299 times 6, if you took 6 times 1300, you get 1800. Subtract 6 from that, you would get 1794, and subtract 13 from that, gets negative 1781. So, there you go. Let's go ahead and take a look at number 10. All right, now they're going to give you 2 terms, the 11th term and the 19th term, and you need to find A, your initial term, and you need to find the common difference, D, and then you can find any equation. Well, based on this right here, which we know, A sub n equals A plus n minus 1 times d, we could say that the 11th term, if I plug that in for 11, so A sub 11 would equal A, which I don't know, plus 11 minus 1 times the d, or in other words, A plus 11 minus 1 is 10, 10d, and I know that is to equal 52, because I'm told that 52 is the 11th term. Now I do the same thing for the 19th term. In other words, if I took A sub 19 and said A plus 19 minus 1 times d. I would get 19 minus 1 is 18, so I get a plus 18d equals 92, because I'm told that the 19th term is 92. At this point in time, I now have two equations with two unknowns. As a system of equations, I'm going to solve it. So if it was me, I'd bring this equation down. A plus 10d equals 52, and I would subtract that whole thing. So the a's would cancel. 18 minus 10 is 8d. 92 minus 52 is 40. So I get the common difference is 5. Now that I know the common difference is 5, I can back substitute it. I'm going to pick this equation up here to back substitute it into. So that would give me a plus 10 times 5 equals 52. So subtract 50 over, and I get a equals 2. So a is 2. So a sub n, any number I want, is 2 plus n minus 1 times common difference of 5. Or if you distribute in the 5, you would get 5n minus 5 plus 2. Or in other words, you would get a sub n equals 5n minus 3. So if you wanted the 1,000th term, plug it in. 5 times 1,000 is 5,000 minus 3 would be 4,997. And let's see if that's what they get. Sure enough, 4,997. Woohoo! All right. Now I'm going to teach you guys how to find what's called a partial sum of an arithmetic sequence. We're just going to add up, not all of the numbers in the sequence, but just parts of them. Okay, so the very first thing we look at is we have the summation notation here, which means we're going to add up from 1 up to 100. Oops. Okay. And of the term of these k's, which is just 1, 2, 3, 4, 5, all the way up to 100. Now there's two ways to do it, okay? There is just a basic equation that they come up with. They actually show you how to get it. If you look through here on 15 and 16, it kind of actually shows you where it comes from. But I would tell you that, honestly, the biggest thing for us is that you know this equation right here. Okay? And I'm going to show you a way to look at it, another way to look at it, okay? So, that's the equation we're going to use, a plus a sub n all over 2. And if we were to do that with this one right here, that means we would take n, so 1 to 100, there's 100 numbers. We would take the first, which is 1, plus the last, which is 100, and we divide by 2. Now, 1 plus 100 is 101. 2 goes into 100 easier, which is 50. 50 times 101 is 5,050. So you can just memorize that equation. It totally works, okay? However, there was, you remember that mathematician we talked about earlier called, his name was Gauss? He actually discovered this pattern as well. Look what happens if you take the first number and add it to the last number. You get 101 in this case. If you take 2, the second number, add it to the second to last number, you get 101. If you take 3 plus the third to the last number, you get 101. If you take 4 plus the fourth to the last number, oh wow, do you see what's happening here? Every time you go up 1 and you come back 1, if you add them together, you get 101. So in other words, how many of these 101s are there going to be? Well, if I have 100 terms and I'm pairing them up into 2s, that would be 100 divided by 2, and that's how many 101s there are going to be. There's going to be 50 times 101, which is what we just got up here, which is 5,050. Got the same answer. Okay, let's take a look at 17. All right, again, here they are. I would this one I think is the most used. Be the one that if I had to memorize one, that's the one I would memorize. Let's look at 18. Find the sum of the first 50 odd numbers. Okay, well, 50 odd numbers. So that tells us how many we're going to do. We're going to do 50. I'm going to divide it by 2. I'm going to take the first odd number, which is 1. The question is, what is the last odd number? Well, let's write up this sequence just for a minute, okay? We have 1, not 2, because 2 is not odd. 3, 5, 7, 9, dot, dot, dot. Okay, so here we're adding 2, adding 2, adding 2. So we're adding 2 every time, so it'd be 2n. But if I put in a 1 for the first term, I want to get out 1. So that means I have to subtract 1 from here. So let's see if that works for 3. If I put in a 2, 2 times 2 is 4, 4 minus 1 is 3. See if it works for 5, which is the third term. 2 times 3 is 6, 6 minus 1 is 5. That works. So 2n minus 1, I want the 50th term because I want 50 odd numbers. So I plug in 50. 2 times 50, which is 100, minus 1 is 99. So I get 1 plus the last term in it, which is 99. So 50 divided by 2 is 25. 1 plus 99 is 100. 25 times 100 is 2500. And you're done. Partial sums, not that difficult. You can do it. Okay. Watch for the next video to come up. I'll talk about geometric. See ya. Bye.